Ignition sequence starts.
Good morning and welcome to Mission Control Houston. This is the International Space Station Flight Control Room, where a team of specialists is always on duty to keep watch over the station systems and assist the station crew members with their science and maintenance activities. Today, the team is working with a crew of 9 people on board for the first time in 5 years. And that crew is starting the transition from Expedition 60 to 61 and getting ready for a new cargo ship to arrive on Saturday morning.
Welcome to Space to Ground. I'm Kayla LaFrance. This week, multiple space launches means busy traffic around the station. On Tuesday, the Japanese Aerospace Exploration Agency, or JAXA, launched a cargo vehicle to the International Space Station following a successful second attempt. Developed and built in Japan, the H-2 transfer vehicle, HTV, is known as Konontori, which means white stork in Japanese. This uncrewed cargo spacecraft delivers science, supplies, and large external payloads to Earth orbit. This most recent launch marks the 8th mission to the station for the HTV spacecraft, and with it carried over 4 tons of cargo, including a set of 6 new lithium-ion batteries that will be installed during future spacewalks. NASA astronauts Christina Cook and Andrew Morgan will welcome the HTV-8 when they capture the cargo craft with the Canadarm2 on Saturday at about 7:15 a.m. Eastern. The population of the orbiting laboratory grew by 3 on Wednesday, when the newest crew members of Expedition 61 launched from the Baikonur Cosmodrome aboard the Soyuz MS-15 spacecraft. NASA astronaut Jessica Muir and cosmonaut Oleg Skripochka were joined by spaceflight participant Hazza Ali Al-Mansouri of the United Arab Emirates on a 6-hour journey to the station. Al-Mansouri is the first astronaut to fly into space from the United Arab Emirates and will spend 8 days aboard the station. He'll return with cosmonaut Alexei Ochinin and NASA astronaut Nick Hague in October, which we'll cover live on NASA TV. The 8 days between the trio's arrival and the departure of Soyuz MS-12 will mark the largest crew the station has seen since September 2015, when 9 crew members were there at once for 7 days during Scott Kelly and Mikhail Kornienko's year-long mission. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Okay, first things first, NASA TV and NASA.gov will start live coverage of arrival of the new Japanese cargo ship tomorrow morning, 4:45 Houston time. Then, be sure to join us on Wednesday morning, October 2nd, for the onboard handover of Station Command from Expedition 60 Commander Alexei Ovchinin to Expedition 61 Commander Luca Parmitano. We'll be back late Wednesday night as Ovchinin, NASA astronaut Nick Hague, and spaceflight participant Hazza Ali Al-Mansouri say goodbye to their crewmates and enter their Soyuz spacecraft to start the trip back to Earth. Coverage of Soyuz undocking starts on Thursday morning, 2 o'clock Houston time, and resumes at 4:30 a.m. Central for the deorbit burn through the landing in Kazakhstan. Now, our coverage will show you a lot of the highlights of a crew return to Earth, but we'll see it all from the outside of the Soyuz vehicle. What's it look like for the departing crew members as they leave their home on orbit and return to the home planet? If you got 60 seconds, here's the insider's view of what a trip to Earth on a Soyuz spacecraft looks like.
Welcome aboard the Soyuz MS spacecraft with non-stop service for Kazakhstan. Our flight time will be just under 3 hours 30 minutes. We'll be descending from an altitude of over 1,300,000 feet. At the time of departure, we're flying at a ground speed of 17,500 miles per hour. Please make sure all carry-on items are secured and that your seatbelt is correctly fastened. Now sit back, relax, and enjoy the flight. Ladies and gentlemen, we are now entering the upper levels of Earth's atmosphere. The estimated temperature outside is over 5,000 degrees Fahrenheit. During this zone of turbulence, we recommend you keep your seatbelt fastened while you're seated. As we start our final descent, our speed is down to 24 feet per second. At 1 second before touchdown, engines on the bottom of the vehicle will fire to soften the landing. On behalf of the entire crew, I'd like to thank you for flying with us. Welcome to Kazakhstan.
This trip to the International Space Station is the first space flight for NASA astronaut Jessica Muir, but it's not her first time in an extreme environment. She studied penguins in Antarctica and mapped caves in Italy, two activities that have prepared her for the ultimate extreme environment.
The thing that's always driven and excited me is exploration in general. So I think I've always been attracted to these extreme environments, places where fewer people have been, where conditions are a little bit more harsh, a little bit more rare, and really extreme in general. I went to the Antarctic 5 times. 4 times was for my PhD research. And the work that we were pursuing then in the Antarctic was looking at the diving physiology of emperor penguins. They use this really big drill to create a hole in the ice, and so you enter the water through that hole in the ice. The first time you go diving through the sea ice hole, you really never forget the feeling. The water down there is a constant -2 Celsius, so 28 degrees Fahrenheit, and you can see rays of light coming in from any crack or hole anywhere around the area. And that's where you start realizing all of the color and the beauty in the Antarctic is. It's just an extraordinary experience, and the things that I saw underwater there is definitely the most remarkable and exceptional diving I've ever had. One of the things that we use for training for spaceflight for astronauts from all of our partner agencies is training in analogs. So if you try to think, what are useful training platforms on the Earth? How do we replicate all of the characteristics of a space mission? One of the analogs that the European Space Agency developed is called CAVES, and it's a technical caving mission. So the CAVES training mission was in this very extraordinary cave in Sardinia. So you would sometimes be crawling through a hole that when you see it in the distance, you don't think there's no way that you could even fit through that. You know, one at a time, we would take off our packs and sort of shimmy like a snake through these tiny, tiny little holes. And then all of a sudden you would come out into this room, this cathedral with a 100-meter granite wall. I mean, it was really just extraordinary. And then we would go on daily excursions, doing scientific experiments, exploring, mapping the cave. So all really similar things that we would do when we finally get to the point of exploring another planet, for example, as astronauts, and then also emphasizing all the other skills that we use on the International Space Station. The other connection that's really important to me is that all of these environments involve natural phenomenon on our planet. So it all goes back to my interest in biology, looking at this remarkable diversity in the animal kingdom with my previous research, exploring all of these amazing landscapes and ecosystems on our planet, and then eventually when I have the most extraordinary of any view, when I'll be on the space station in a couple months, looking down and seeing this magnificent planet Earth and seeing the beauty of our planet and really understanding how special it is and how fragile it is and how important it is to protect it, to take good care of our home planet, to protect our oceans, to protect the land, and to be really a good steward in our universe. I'm Jessica Muir. I'm a scientist and a NASA astronaut.
International Space Station training does not require that an astronaut submerge himself under several feet of ice or hike to the center of the Earth. But the course of preparation for a 6-month tour of duty on the International Space Station does last for more than 2 years, and it has its own tough elements. Modern technology allows astronauts to train more safely than in the past as they prepare for the missions of today and of the future.
Mission training for astronauts has always been rigorous. Testing our astronauts' limits, abilities, and knowledge is still an integral part of readying them for the tasks they'll carry out in space. In the Apollo era, there were so many more unknowns. Those pioneers used the best of what was available to them at that time and invented the rest. Safety was and is a top concern. But we push boundaries at NASA at great risk. Throughout NASA's history, technology has fueled the evolution of our training programs. Virtual reality allows our astronauts the benefit of safely repeating mission-specific events and activities, although some things we do don't look that different from back then. Astronauts have to be prepared for their journeys. It's the nature of all of those who explore.
The International Space Station serves as a one-of-a-kind platform for scientific research, taking advantage of the microgravity conditions to perform experiments that can't be done down here on the planet. That includes experiments in an atomic refrigerator that's capable of cooling matter down to just above the point where, in theory, the thermal activity of the atoms comes to a stop.
Cool Science on the International Space Station. Presented by Science at NASA. NASA researchers are creating a spot colder than the vacuum of space inside the International Space Station. It's called the Cold Atom Lab, or CAL, and it can refrigerate matter to 1/10 billionth of a degree above absolute zero, just above the point where all the thermal activity of atoms theoretically stops. At this temperature, atoms lose their energy and start to move very slowly, explains Rob Thompson, CAL project scientist at NASA's Jet Propulsion Laboratory, or JPL. At room temperature, atoms bounce off each other in all directions at a few hundred meters per second. But in CAL, they'll slow down a millionfold and condense into unique states of quantum matter. CAL is a multi-user facility that supports many investigators studying a broad range of topics. Eric Cornell, a physicist at the University of Colorado and the National Institute of Standards and Technology, will be leading one of the first CAL experiments. Cornell and his team will use CAL to investigate particle collisions and how particles interact with one another. Ultra-cold gases produced by the Cold Atom Lab can contain molecules with 3 atoms each, but which are 1,000 times bigger than a typical molecule. This results in a low-density, fluffy molecule that quickly falls apart unless it is kept extremely cold. How is particle behavior affected as more particles are introduced? What can be learned about quantum objects when several atoms are interacting at the same time? Cornell says the way atoms behave in this state gets very complex, surprising, and counterintuitive, and that's why we're doing this. Cornell shared the 2001 Nobel Prize in Physics for creating Bose-Einstein Condensates, another state of quantum matter that can be studied inside CAL. Bose-Einstein Condensates are essentially blobs of quantum matter that look and behave like waves that exist at these ultra-cold temperatures. In the free fall of space, the condensates can hold their wave-like forms for 5 to 10 seconds, much longer than on Earth, providing researchers a window into the quantum realm. Thompson says we can use CAL to test general relativity and quantum mechanics. One of the biggest questions in physics today is how those two work together. University of Rochester physicist Nick Bigelow and University of Berkeley scientist Holger Muir, along with their colleagues, plan to use CAL to test a cornerstone of Einstein's theory of relativity, the equivalence principle, which holds that gravity and external acceleration cannot be distinguished experimentally. They plan to repeat Galileo's iconic experiment dropping cannonballs off the Leaning Tower of Pisa, but using atoms instead. Dropping atoms inside CAL and letting them fall for several seconds as the station orbits Earth will allow researchers to precisely figure out the differences between how the atoms accelerate. This experiment may reveal how gravity and spacetime are woven through the quantum realm. A researcher at JPL named Jason Williams also plans to use ultra-cold 2-atom molecules to develop tools for the next generation of precision gravity tests with quantum gases. Many more experiments are planned for this cool new laboratory, and no one knows where they will lead. With CAL, says Thompson, we're entering the unknown. For more from the International Space Station, visit www.nasa.gov/station. for cutting-edge physics on and around Earth. Stay tuned to science.nasa.gov.
Now, along with doing hands-on science in the International Space Station's laboratories, the crew members have been talking directly with students on the ground to share their experience. And some of the astronauts have been making fun instructional videos up in zero-G. In this installment of the STEMonstration series, Scott Tingle demonstrates the orbit of spacecraft and offers viewers a chance to participate.
Hello, my name is Scott Tingle, and I'm living and working on board the International Space Station. You know, I love my views from the cupola. It's our orbiting altitude of around 400 kilometers or 250 miles above the Earth's surface that gives us these unique perspectives. Let's explore how our ISS orbits work. Come on. First, I should explain, orbits are elliptical or oval in shape, with some being almost circular. Planets, comets, and moons have elliptical orbits. Spacecraft, orbiting Earth like the space station, are placed into a nearly circular orbit to keep a consistent altitude as they travel around the planet. Let's take a look at the Earth. It has a radius of 6,378 kilometers, and the station orbits about 400 kilometers above the surface at 8 kilometers per second. That's 17,500 miles per hour. See if you can use these values to calculate how far and how long we travel in one orbit around the Earth. All of this information and more activities related to orbits are available in the accompanying lesson plan at nasa.gov/STEM on station.
Answers coming in.
4, 3, 2, 1.
The answers to the questions, by the way, are approximately 42,600 kilometers and 90 minutes. And due to our altitude on orbit, we have our very unique and awesome view of the Earth. Thanks for exploring with me today. I'm going to send you back to Earth now so you can start your challenge on orbits. See you again soon.
A tool that helps guide sailors across the oceans for centuries is being tested on the International Space Station now. In this experiment, researchers are looking into the use of a handheld sextant as a potential emergency navigation tool for guiding spacecraft across the cosmos.
They can use their sextant. An astronaut lines up a known star and a prominent landmark, and feeding his readings into the computer, gets his position back from the machine.
John's pointing right now at the sextant and a telescope, which are our navigation means to get home.
NASA's Human Research Program is using the International Space Station to learn more about how living in space impacts the human body, so we can figure out how to counteract the negative effects and protect future astronauts when they explore out beyond Earth orbit. That includes dealing with the radiation that astronauts are exposed to when they're outside the protection of Earth's atmosphere. In this installment of a series on space radiation, HRP scientists discuss the biological risks that future astronauts will face on missions out into the solar system.
So of all the things that the Human Research Program is investigating, the biological consequences of radiation exposure is one of the major ones. Some of the reasons for that is that the health consequences following radiation exposure are very complex processes. It's difficult to quantify exactly how the radiation is interacting with tissue, and then it's even more complicated to try to quantify and determine what the long-term outcomes are going to be in terms of things like carcinogenesis, central nervous system effects, and detriment to the central nervous system.
The primary means by which radiation affects cells is by damaging their DNA. You can get breaks in the strands in the double helix, you can knock bases out, and the cell will make an attempt to repair that damage. Sometimes it's effective, sometimes it's not, and sometimes it'll actually get repaired, but in an error-prone fashion, so it's what we call misrepaired. So anything that sets into the genome in that way is a mutation, and the accumulation of mutations can potentially lead to cancer and take a non-cancerous cell, a normal cell, and make it transformed into a cancerous one, so that's a big concern.
So on Earth, there's a couple characteristic things that are different from space. One of them is that the type of radiation we experience on Earth is generally what we refer to as low LET radiation, things like gamma rays and X-rays. We also have the protective shielding of the Earth's magnetic field and the atmosphere, which shields a great deal of the radiation. And then finally, we have things like radiation protection concepts such as time, shielding, and distance. So we can reduce the time of exposure on Earth, we can reduce the distance from the radiation sources, and we can reduce the exposure through shielding. In space, a lot of those things are very different. So we have a very complex radiation field that includes things like protons and all the particles on the periodic table of elements. They're coming in at energies that are approaching the speed of light, and they're difficult to shield against, and they're always there. So the concept of time really doesn't make sense because you can't reduce the exposure in space except perhaps getting to Mars faster. You can't really reduce the distance at all because the radiation is everywhere. And shielding concepts for galactic cosmic rays are very difficult because of the energies involved.
There have been 60 expeditions on the International Space Station since the year 2000, and more to come, and all of them have worked to achieve scientific goals while getting humankind ready for the next step in space exploration. And that's moving out beyond low Earth orbit to return to the moon by 2024, and then out into the solar system to Mars. NASA is building the systems right now that will take us to our next destination.
50 years ago, we pioneered a path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible.
It's very pretty out here.
Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off-planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
and more in testing,
this system is capable of being the catalyst for deep space missions.
We need a capsule
that can support humans from launch
through deep space and return safely back to Earth.
For this, we've built Orion.
This is NASA's next-generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources,
We're currently developing an entirely new approach to landing and operating on the moon.
Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
Our charge is to go quickly and to stay, to press our collective efforts forward with a fervor that will see us return to the moon in a manner that is wholly different than 50 years ago.
We want lunar landers that are reusable.
That can land anywhere on the lunar surface.
The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits.
It will balance between the Earth and Moon's gravity,
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water. It can be separated in oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and onto Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see it with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going.
We're going.
If you'd like to get another look at any of these stories we showed you today, check us out on YouTube and on Facebook. There are the addresses in the handy blue screen. While you're out there, look around because you're going to find a lot of other cool stuff about NASA and America's human spaceflight program. And while you're out on the internet anyway, check out Houston We Have a Podcast, where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday. Today, Gary Jordan talks with Benji Reed of SpaceX to get the introductory lesson on the SpaceX Crew Dragon. It's a complimentary episode to our recent education on the Boeing Starliner. Go to nasa.gov/podcasts for today's episode. That is also where you can find all of our previous episodes, as well as the full library of all of the NASA podcasts. And all of them are also available on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.